Okay, thanks a lot for the introduction. Yeah, my name is Michael. I work as a Java developer at a postcode lottery, the Dutch one, not the German one. Um, yeah, and yeah, thanks for the introduction. And I want to tell something about strings in Java, and it seems to be quite a basic topic. So I think everybody who's a Java developer knows something about strings, a bit how it works, and um, but while doing this research, or while preparing this talk, I found a lot of things that I actually did not really know, or I kind of knew more or less, but I didn't really know how it works. And I had quite some fun to research all of this. And I hope that if there is one new thing for everybody here, I will be happy. So, I mean, I assume that most people who develop Java know a lot of these things. I also have actually, I think, too many slides. I might just skip a few at the end. Well, we will see how far we get because it's the first time I do this talk, so we will see. So I will just see. Is it? Yes, you see what I see. That's perfect. So maybe just the first simple question: what is actually a string? I mean, this is one. And the definition is actually a sequence of characters in a defined order. And there are only a few things in this sentence which are kind of important for what we're going to look at. First of all, it's a sequence, it's characters, and the order is defined, which is kind of obviously important for a lot of properties, because if it was random or kind of a set, not defined, then yeah, a lot of things would not work as they do. So this is a string. It's a saying in English. I thought it kind of fits to this talk. No strings attached, even though there are quite some strings attached on this talk. Let's see. And then this was one of the videos where I thought, okay, this might be an interesting topic for a talk on this. It's actually a 1 hour video, but I'm just showing 1 minute here. This is James Gosling. Most of you probably know, is a creator of Java. And he had only like a few months ago, he had this talk on the JVM language in the US. Yeah, he somehow mentioned strings, and it was exactly what I was also thinking a little bit. So I'm going to just show this as a introduction for motivation. Let's see if this does not work. I want to play this. It doesn't work. Great. I was afraid of this, that it doesn't work with that screen. Well, I go to the next slide, but I will quickly summarize what he said, because this is the important thing. So what he actually said is that it's fascinating for him, and he created Java like in the 90s basically, that there are still people on a conference from Oracle who have hour-long talks only about string concatenation and how strings work in Java, and that there's still updates, still nowadays. So, and this is for him fascinating. So this was. I have reference in the end if someone wants to watch the video also about the string concatenation, but it's a 1 hour talk about string concatenation, so I have it like in the appendix of this talk. So, well, this was my inspiration for this. And the first thing I also ask myself, because I always find these things interesting, the word string, where does it actually come from? So, because actually in English it's just basically a thread, like a piece of small rope or something. This is where it's coming from. But how did it end up actually in programming and computer science? And I did some research on this, and this is actually the oldest reference to the word string. And where it actually comes from printing, these old printing machines, where you had to typeset with little blocks of metal, all the letters. And what they actually did is for test, they printed this out on just a long piece of paper, and they called this a string. And this then evolved the first computers and these kind of things. So there's a little bit of the history. And I think I don't know, probably most of you speak German or are German, I don't know. The German word is Zeichenkette for string, which is actually very descriptive, because it's basically character chain, which I find nicely describes the whole thing, because a chain, it's immutable, you cannot really break it up. And it's like also a sequence of characters, basically. Okay, this as an introduction. Now, why are strings actually special in Java? So, because they have quite some properties that other things do not have. So first of all, strings are actually literals. You can just have it in the code, right? However, they're not like ints or bytes or floats or something. They're not primitive types. They're actually classes, but you can have them as literals in the code. So that makes them actually quite special. It's a class, but you have it as literal. And yeah, probably everybody can read this. It's actually the only type, actually, apart from the wrapper classes, but that works differently, where the plus operator is overloaded. Because normally you cannot overload operators in Java, but in string, for the string, this one is overloaded. And you can call a method, like in this case, to uppercase, you can call it directly on the literal. So this doesn't work with other things. You cannot call a method just on one in the code. That doesn't work. So strings are the only the only object where that actually works. And string is actually the most used classes in Java, because it's used everywhere in the JVM for class loading, for everything. And I tried actually to do this just to prove it. So if you go to the string class, for example, or to string builder, string buffer, something, you put just the breakpoint there. You run print hello world in there, and you get a breakpoint that stops like all the time. You cannot even press that much. It just continues, because all the class loading, it works always the string internally. So this is why this is actually a really important, important concept. Also the special treatment where we're going to talk later about is also, there's this string pool. Probably most people know about the existence of this. So that all of this makes actually strings rather special. So also one thing I thought you should know about it. Let's go to the next slide. One of the basic properties that is actually quite common is, or that most people actually know, but is that strings are immutable. So now, if you start developing in Java, you may be new, and you might be doing this, writing this code here. So you have a string, it says Java, and then you say to uppercase. You might expect that this variable language contains now Java in uppercase, but it doesn't, because it's immutable. So actually, you need to use the return value of this. So if you print this out, you get Java, and you might first, if you knew, well, why is this? But I made it to uppercase, so why does it not work? Why are strings immutable? And there are a lot of reasons for this. The first one is security, because this class is used like everywhere. It's also used to read files, to establish network connection, to connect to a database. So the designers of Java decided it's a good idea to have it immutable for just security, that cannot be a database connection or credential cannot just be modified by maybe some library or accidentally the code or something like this. It also helps with synchronization because it's immutable. If you have a different thread, you always know that string is that string, so it is not mutated. Because any other, if you call a method and you have like a primitive value to this, it creates a copy of it. If you have a class, then it's by reference. So if this class is mutable, then you can modify it in that method, and the caller might not know this, but with string that doesn't work because it's immutable. So you can be sure if you pass it to that method, then it will stay the same. And this is especially also for the class loading, because if you accidentally modified something like this, like if you modify the name of a class, you would basically, like, if it wasn't immutable, you would basically just kind of cause a lot of problems in your code, obviously. Then it's also it's good. It enables certain performance things, like for example the string pool, because if it wasn't immutable, then the string pool could not work as it does now. We're gonna look at this later. And you can also cache the hash code. This is actually a copy from the actual implementation here. And this only works because the string is immutable. So this is actually the actual implementation copied from the string class. And as you can see, that if the hash doesn't exist, it will compute it. If not, it will just return it. And it is actually quite important. You might think, okay, it's not so much this computation, right? However, this is used everywhere, like as a key for like in a hash map, in a hash set, and basically everywhere. If you read it this all the time, that would be, this would be much less performant, basically. This is one of the things you can. Why this immutable? Now, going further on the implementation of string, I looked a bit in the actual code and how this evolved now over time from in the different Java versions. And actually quite some interesting things. So before Java, or up until Java 6, you see that internally the string was stored in a character array called value, and there was an offset, a count, and the hash. Now, this so the actual string was basically was stored in here, immutable, obviously, and there was also the count and the offset. And using this, if you did, for example, a substring on that string, it did not have to create a new string, but it would just say, okay, I have the substring from in that string from, I don't know, 3rd place to the 10th place. And it did not have to copy that character value. So this was how the substring was implemented until Java 6. Then, however, that there is also a JAP something for this, a Java enhancement process. You can find this online with some explanation why there was some performance synchronization problems with that. And in Java 7.8, this was removed. So there was only so this is now from a different Java version. I copied this, and there's only the character array and there's only the hash. So that means if you're now at that as of Java 7, if you called substring, for example, it would copy that part of the original string just to a new array. So it basically took longer. One of there are a few explanations for this on the Oracle website. That there were, as I said, synchronization problems with threads and so on. And they also did some research that apparently the performance problem impact is not that big, so they decided we can do that. It's, by the way, it's quite interesting to dig into this because you can also go to GitHub. Actually, you can see all the Java code of all the different versions still. So if you want to see how certain code evolved, you can just go to GitHub and follow it. Which is sometimes the only way, because some of the old Java versions you cannot even install on a Mac. It's a bit difficult if you want to install a Java 4 here, for example. That will be difficult to get this running without a lot of effort. Unfortunately, it would be nice for these kind of presentations. Now, as of Java 9, you see there is now more. There are quite some differences here now. First of all, the character array changed to byte, and there is an encoding here. There's again the hash value, and there's a boolean for compact strings. Just need to see if yes, it's here. So what basically happened here is that we're going to see some examples later on, but Java basically stores Unicode, which has 16 bits, so it's actually 2 bytes, so this is exactly the character. However, this, mostly this is not really used, right? If you write English or something, we don't need all these special characters of the Unicode. So as of Java 9, implementation change that said we store this as a byte, so this is only 8 bits, but that means you cannot use the whole Unicode obviously. But it's usually, let's say, is enough. However, if you want to have the whole Unicode, then it uses 2 bytes actually. So it's not stored in 1 character, but it's in it just uses 2 of the bytes. That means, as of Java 9, the maximum length of a string, if you use the full Unicode, is actually shorter, because you still have the maximum array size of, what is it, 2 billion something in Java. And if you then use 2, basically it halves it, but most of the time this is not a problem. Now, the question is now how does it actually work now? So, for example, if you want to calculate the length of the string, but you need to know, is this now UTF-16, so this is Unicode, or is it just the normal, the Latin 1, it's I think called the code, which has only 1 byte. So if you check the implementation, what you see is actually all the methods, like this, for example, the length. So this is basically division by 2, and all the methods have an if-else here, so they check if it's 1 byte or if it should be Unicode with this, and yeah, they're basically all else if. And but however, by doing so, as we mostly use English, some European languages, something that doesn't use Unicode, the memory used goes actually really down. It's basically halved. Now, a few funny things about this, as you can use Unicode. And imagine you did this. There's a little riddle actually. What does this print? It's the length of these strings, and there are 4 of them. So if you count here, this should be 5, right? 4, 3, plus 3. It's probably the expectations. Anyone has a different opinion? What this could print? Any guesstimations? Sorry? Yeah, no, but I mean, what will be the output of the length of the strings? Yeah, so that would be 5, right? 4, 3, 3 or something like. Why 6? It's 6. Yes, sorry, 6. Oh, okay. Now, yeah, we're gonna also have some explanations about this, but it basically gonna print this. Question is why. This one is obvious. It's 6, right? It is also because this can still be represented with Unicode, basically, with the short version, let's say. Now this here is what I just tried to explain, because this actually has 2 bytes, because it's part of that Unicode, which is above the 1 byte, basically. The problem is the string length counts the Unicode. It counts the bytes, not the characters anymore, because it counts the bytes, but it's 2 byte, so it prints this. In this case here. Now here, this is a different issue. So basically, these 2 here print. This is 1. And this is also 2. I do have and if you now think, okay, this is wrong, right? It seems like not to be logical. Yes, that's correct. There is a solution to this, which is actually this. You can tell it count the actual characters, so code point count, which you can do, and that counts the actual, because Java basically knows which bytes need to be followed by a second one. So that can be in the Unicode table. You can download this somewhere on the internet, and it knows after this there needs to be another one. So it can count it correctly, but you need to tell it explicitly, because the other one simply counts the bytes. Yes, this is unfortunately not the full story. It gets way more complicated, but this Unicode encoding is extremely complicated, so I don't want to go so much into this. What did I actually accidentally copy this, because I think that yes. Oh, this one was yes. Now the implication of this is you might have sometimes maybe some kind of a task, some small thing of online coding, some interview questions or whatever, and you do this. Seems logical, right? Print reverse. So you basically just take the string array, you turn it around and print it out. Now, with the same 4 strings I had before, if you do this, you will basically get this. Yeah, the question is why, because these bytes are actually turned around, but then it doesn't work anymore. Because you had the 2 bytes for these emojis. So, but to display it correctly, you have to do this first and then this one. But it means if you reverse the string, you need to take these two and consider it as one, but it doesn't work like this. So then you get question marks actually. So so if you want to reverse the string, you actually should use a library function. You basically do a let me quickly think. It was, I think, string doesn't have it, but you can have string builder. I think it has reverse, and it does this correctly actually because it's considered. But the code for this reverse is incredibly complicated because it needs to consider all these weird cases. Now, a little fun story about this actually. It is not directly connected to Java, but as I said, this is not the full story because some of them have way more bytes actually. And this needs to be all considered by displaying it. IntelliJ does that, by the way, because I copied this with IntelliJ. So there was this story actually here, and I did read this. One of my hobbies is climbing, by the way, so mostly indoors. And there was like 1 or 2 years ago, I think there was in a climbing magazine, there was this story that there was no climbing emoji. Didn't exist. But you might have seen that this exists now on your phone. You can send this if you want. And there was a professional climber from, now I need to think, where actually from, US, I think. She figured this out and she contacted this the organization. There's actually an organization who creates emojis that exists. And it's a very, and it was really funny, this article, and this is why I remembered it, that she explained how she contacted them, and it was a 1-year process only to get this emoji to everywhere. To the iPhone, to all the devices, Android or whatever, an incredible complicated process. Now, how is this related to this? Because it has 4 different bytes basically in Java. So if you try to reverse it, that obviously becomes complicated. So the first thing is basically the climber. So this is this one here. This would be 1 byte. The second one is a joiner symbol, which tells this is not a new character, but it's like to modify this one here. And then this one here is like all these modifications you have nowadays. So this one tells it, okay, this is a female one, and it's a white one. Because you have you probably know it. If you have thumbs up or something, you can choose different colors. But this is not a different Unicode code actually. But it's there's the joiner in between, and it tells them the next one kind of modifies the character before. So it has a thumbs up, and then please make it yellow, or I don't know, brown, or red, or something else. And yes, and this is actually also an explanation why this. All the code, if you look at string in Java, it's quite complicated with all these encodings. You have a question?
Yeah, so if I had a device that doesn't support this new emoji,
Yeah.
it probably displayed like the male climber and the female sign, right?
Yes, that actually is the case. I tried to do this in IntelliJ, for example. It does do that correctly, but it's actually kind of really weird if you copy this from somewhere. What it is doing is it first copies the actual original climber, it copies the female sign, and then it suddenly joins together. It looks really funny. It's, yeah. Or yeah, if you're unlucky, you get question marks after it. It depends a little bit.
Oh, it's kind of clever, so it's still downwards
Yeah.
compatible, right?
But it makes it actually quite complicated from a programmer's perspective, this whole thing. Okay, this was a bit of fun intervention. Now we go to the next one. That's the string pool. I think probably everybody has heard about the string pool, but yeah, what is it? What is it actually doing? How does it work? I don't want to talk too much about it. So maybe first of all, if you look at the implementation of this, you don't see directly in Java. There will be the keyboard native because it's actually implemented not directly in Java. It's somewhere in a JVM somehow. And I think it's C code, C++ maybe. But maybe the important takeaways is that usually variables and so references, variables and meaning references to classes and primitive data types in Java stored on the stack, and classes are in the heap. So, and as a string is a class, so that means the actual string lives in the heap, and the references to that is on the stack. Now, if you have a constant in Java, it goes to the string pool, if it's the same, I mean. But if you create a new string, even if this is the same, it will be a separate object here, somewhere referenced. Yeah, basically this is the general concept. And I have one slide in between. Let us see. One thing is, this is also the reason why you should actually not have any sensitive data actually as a string or as a constant, because it will end up in the string pool, and you can actually not just empty it or something like this. So there is no method like empty my string pool or something like this. Okay, there might be some hacks, I don't know, but in general it doesn't work. So normally this is actually written on the even on the Oracle how do they call it? I think in the what's the name again? Cryptographic architecture guidelines, something like this. It's actually recommended this way, because if you do this and you just fill it up with 0, this will stay on the stack, and this will be overwritten. But if you have it actually as a string, and it ends up, for example, in somewhere in the string pool, or then if you do things like, I don't know, what can you do, a heap dump or something, you might print this all out or store it somewhere, and we might not want this, obviously. Now, there is one thing that also exists that I think is less known, I think. So there's the string pool. So if you have a string if you have two strings that are the same, constants at least, you get that string pool. Now, there is another thing, it is string deduplication, that sounds a little bit the same, but it's actually not the same. And that also has changed during different Java versions. So what is this actually? So I'm trying to make one example here. Actually, there are quite some implementation details in the JAP something for this, but there's a bit a high-level overview. So let's say you have in the stack, you have these three strings. So this has a Java string, and then you have twice one with the same value, my string. And string pool is empty in this example. And these are all different objects with three different byte arrays. We call it my string, and Java string. Now, as you might know, you can if it's not a constant, you can call on the string, you can call intern, and we'll put this one also in the string pool. So basically just by default, let's say, only constants go in there, the string pool. But if you have a string that you've constructed yourself, or that you have read from somewhere, you can call string intern, and it will go to the string pool. Now, this is basically what happens. So I call intern, it goes in here. Now, these ones here, that was, did I write it down, which Java version it was? It was 8, I think. Okay, it's maybe not that important. There was also string deduplication introduced, and this is not exactly the same. So what basically happens is that this string, it's the same. So if you also called intern and this, it would obviously go here. But what the JVM is basically doing, it sees, okay, here are two byte arrays that have the same value, so my string in this case, and it references then internally the same byte array. But this is different from the string pool, because here you still have two different objects, basically. So these are still two objects in the heap, but they only reference, so they both have a reference to a byte array, and they reference the same one. That means you still, if you do, you still need string equals with it. So if you do equal, it still will be different. While if they end up in the string pool and you do equals, you will have, it will be true, but in this case it will still be false, even though it's the same byte array. So that's basically the difference between the string pool and string deduplication. Now, a few words about this. This originally only, and you find actually still a lot of blog posts mention this, that it was only for the so-called G1 garbage collector. For the other ones, it wasn't implemented. However, it was as of Java 18 also implemented for these three. So maybe we hear something about garbage collection later, I think. But anyway, it's as of Java 18, it also it was implemented for these. However, it's disabled by default, and you can enable it with this. Which, I mean, it's probably only if you do somehow a lot of things with strings that you expect to be the same that makes it worth. So, but obviously performance is always like, you know, case by case basis, and no general things there. Yeah, I think that was it about string deduplication. So then there was this. Yes, I normally I never use AI, by the way. So and I thought, okay, let's try ChatGPT because everybody is so fascinated about this. Let's ask him, tell me something about strings that most people do not know. I was unfortunately like a little bit disappointed with the answer. I just did this for fun. So, well, he came up with this. That was very disappointing. Lesser known aspect, strings are immutable. I think most Java developers know this or should know this, so that was the first disappointment. And then the next thing was this. String concatenation using the plus operator creates new string objects repeatedly. And this might be partially correct, but then the only thing was this, and then he gave an example that I don't have here. There was a piece of code. The code was at least correct, but that was it. So that was all he told me. So I was a little bit disappointed. But this leads me to the next topic, which is string concatenation. And as I said, there was even at this Java Summit from Oracle, there was like a 1 hour talk about this. Very, very detailed, extremely nerdy. And I thought, okay, let's put something in this. So there was someone from Open Value who had like a short time ago, we had this on LinkedIn. So I thought this fits. I don't know, has everybody seen this? It was on LinkedIn for Valentine's Day. And I thought this just fit because this is a string concatenation. So I thought this fits to the talk. So let's see. Because the string concatenation is done with a plus here, as you can see. So the question is, should this be done? Because it's always recommended, no blocks don't do that. Don't do a plus in Java. Use string builder, use something else for this. And here, there we are. At least these people are, the one who, I don't know who made this, but he was very up to date. At least there's the reduce main and so on. So this is a kind of nice. There's a statically imported print line. It might be removed because it's a preview feature, because IntelliJ warns you if you do this still. Yeah. To
I think they changed it to this the recommendation to using plus sign.
Yeah, this is the question. We will talk about this now. It's an extreme, it's a very complicated topic, but I don't want to make a PhD on this, so because this is namely the question: does this happen? Does it happen? So let's have a look. First of all, I made a Java 8 version of this because I wanted to look at the bytecode and I wanted to compare the different Java versions. What's going to happen? So Java 8. So this is Java 8 now. So I just added a class here, you know, and the system out print line to do this. And now let's see. I hope that isn't too small, but you're not too far away, right? So this is the bytecode. So this is the. I don't know if everybody is familiar with bytecode so much. I mean, I cannot write this myself, but it's actually not. If you do this a few times, not that difficult to read. Does everybody know how to get this? Actually, you can do it on the command line. I can do it, but you can IntelliJ. I can just show bytecode. But the important thing is here. What's happening? Here, you see, string builder append. So you were basically right. This happens. This was, I think, as of, tried to look it up, but it was actually as of Java 1 or 2 already, because I figured this out first, that this is not a good idea with the concatenation with too many classes generated. So, but it is Java 8, and there we are. So there ChatGPT was kind of right. So that means this recommendation that you read a lot, also in books and everything, actually doesn't especially make sense in this case. Now, Java 23, and this is 23, but it was as of 9 actually. it's the same code. There's no string builder there. There's a make concat with constant somehow, invoke dynamic. Okay, interesting. So actually I had never seen this before, so I didn't, because I also thought I had read something like this, a string builder replacement, but I was like, okay, what is this now? And actually only about this, there was this 1 hour talk about string concatenation, how the thing works. Now, this is going to be short. So basically what happens here is that this make contact with constants references another method basically that can be how to say it? So, because it's not especially string builder anymore, it is just something, so to say, that can be easily replaced. So you don't need to change the bytecode anymore. So it can be replaced in JVM, for example, and that means the optimizations to that string calculation can be done without changing the bytecode. So this can basically stay for probably quite some versions of, I don't know how long, and this basically implements the string concatenation. So there's no string builder anymore, so there's this. There are some disadvantages. You can also set a flag somewhere that says use string builder still internally for this, if you have some problems with that. There are some problems with that, but let's not go into this. I'm also not an expert on this. This was really very deep into how things work. Now, there is still a remaining question. What about loops? Because this is also the thing, this is always mentioned, like, if you have a loop and you build up that string, what then? Because then it's not a constant anymore, so does it still work, string builder, or what's going to happen? So I made this is actually quite simple. So let's have a look. This is Java 23 in this case, but it's also as of 9. You have this. So that means actually even in a loop, you can do that. Shouldn't be a problem. There are obviously a few catches with that. It might still be useful to use something else like string builder, for example. You can allocate the buffer that is in there, like you can tell it, okay, this will be 1000 long, then you don't need dynamic allocation or something, but then it might be worth to do that, but it's really only if you have some performance problems, then it's very specific. So in general, you can use the plus basically nowadays, or actually for quite some time. So this is, it's not completely fake news that you shouldn't use the plus, but it's mostly, because it's still like kind of very historic, let's say.
I think Sonar would complain still if you use
Too.
concatenation. Sonar cube will complain if you use concatenation with a loop.
Yes, but because it depends a little bit what exactly you're doing. There might be, of course, scenarios where this, but not for simple things, let's say, not for simple cases. Because as you can see, it is being replaced already. So, yeah. What was the next thing? Yes, this is this is maybe not so important, but this is for reference. This is the JEP 280 with where this change was introduced, and there were some bugs actually with it. And this is actually, I mean, we don't really have to understand this parameter here, but what is interesting is that this is JDK 23. This is actually quite recent, so that it's still actually working on string concatenation. So this is still being improved and updated and everything. And this parameter was only added in 23, so that you can say, depending on how many parameters you have in this make concatenate function, that sometimes it will just be not used basically, or replaced by string builder, or how exactly that internally works. So there's still, it seems to be simple string concatenation, but there's still like people working kind of full time on these kind of things. You can find talks on this, and it is explained, and it's yes, actually, I think I've misplaced the slide. It should have probably become in the before that. But anyway, So, and yeah, obviously, I mean, maybe if you're new to Java or still nowadays, sometimes you think, okay, you have all these possibilities to join to the string. It's quite a lot, right? Because you have the plus, you have contact, string buffer, string builder. Then you have this format that they can directly call here, for example. I think this is also still rather new, I think. You have join, string joiner, and you can do a stream basically here. I mean, this is maybe a bit too explicit, but it's possible. And then there's the question, what of these to use actually? So but they have different use cases. So it's kind of, I think, always good to know the whole spectrum. At least if you want to call yourself a professional Java developer, right? To kind of know why things are like this and what are the possibilities, because sometimes the one might be better or more readable than the others, more performant. Sometimes it's just about readability, right? It doesn't have to be about performance, but for some reason one might sometimes be easier to understand than the other. Now, the next few slides I just made, because this is about strings, also something a bit practical. Quick overview of all the changes of strings from actually 8 to, I think, to not even sure to which version. Yeah, just because Java is so much evolving nowadays, and it sometimes can be hard to keep up with everything, right? And especially when you look at blogs here and there online or books, and then there's always stuff not mentioned or it is even wrong. So just a quick overview about this. So as of Java 8, so it has been a while, but it's still interesting to know, because a few years ago I was on a project we still had Java 6, meaning this did not work. You could not use the string here. Basically, you could only have primitive types. And I knew that this was possible, another version. So I was still in Java 6. No, that doesn't work here again. And it was actually quite useful to have this, right? And then I noticed it. Still in Java 6, it doesn't work. Would be useful to have it. Then 11. There were quite some things added here. Strip, trailing, leading, repeat, and is blank. Yeah, okay, I mean, strip, trailing, and leading, this is kind of clear, it didn't exist before. Strip, you might ask, why strip? Because there's already trim, it does the same, basically. You might think, but it doesn't, because it's related to the Unicode problem, because there are more, let's say, blank characters in there than there were before. So the trim does not work on everything that's actually blank in Unicode, so this considers Unicode. Is blank, and then there's the same issue. And repeat. I'm not sure how useful that repeat is, but it was added. Then we have 12. There was indent added, and transform. Indent. Well, I've never used this actually. This one here is, I think the main use case for this is that you can also use it like in streams to do certain things there. 15, there was also something added, these text blocks. I find this actually quite useful, especially in tests when you want to have something a bit like an SQL like this and there, or maybe some HTML or some kind of a template or something. Maybe quick question between, how much time do we still have?
I guess -5 minutes.
Oh my God, I've been talking that long. Oh, damn it. And I tried to, there was actually, we're getting to the end. This is actually good. Because I had some more, but so then a little bit about the future actually, because we talked about a lot what was there now. There was one thing added, string templates. I don't know if you have seen this, but it was twice in preview and then it was removed. So it basically looked like this. So the motivation was like it would be nice to have in Java something like this. So you have the variables here, and you could just put it in here. That exists in a lot of languages, right? So this is an example. You have Kotlin here, you have Python here, and this will be interpolated here. That doesn't work in Java. So I tried to do this, but with a really strange syntax from my point of view. I mean, it just looks weird. There was this processor here, then a dot in front of the string, and then slash curly parentheses. And there were a lot of discussions in forums online, and then then it was removed. So there's a bit of history here. So it was first, second preview, and then there was this one here, and it was actually just before the release. Goodbye. Now, I try to understand why this happened. Actually, I try to be fast now. This is a comment here. There was actually two long entries in the mail, and in I think it was Stack Overflow. I think from Brian Götz, that's the chief architect of Java. He tried to explain to people why this actually happened. I obviously didn't copy this here because there's, I think, 2 A4 pages. But the most important things are that that the reason was not that someone didn't like the syntax. What I think maybe many people did like, when I also thought this is kind of weird, but it was not the reason. But they apparently discovered some flaws and whatever in this. And there are now, I think, somewhere a few possible other things how it could be done, but it's completely in the air. It might actually never happen. Who knows? Maybe something a bit more interesting, and this is Project Valhalla. I'm not sure how familiar with that, but it's basically having value classes. And this is actually also, there is namely also somewhere written something about string in there. If you go to the, it's somewhere there. But I found this basically, that strings at the moment not in the list for now, but that they are probably considered or might be considered in the future. So this is from him, but this is still like discussion and future and whatever. Still, takeaway from this is that the whole string story is absolutely still evolving and not just finished. So it is not just a string, but something. It's basically also a moving target, at least if you look really deep into it and how it works. So I'm probably like at minus 10 minutes now. So to the last slide, because I put the slides and also like a list of references. I can watch the video and read about. Actually, all the references I used for this I put also in a markup file on GitHub. So if someone is interested in this, you can copy this QR code. Or I thought you put this video also somewhere. You can probably do it later. And then thanks a lot for listening. And don't know, do you have any questions still? Don't know if there's time for this, but
yeah, I guess we have some time. Thank you very much. So at least I learned a few things I did not know before about strings. So it's time for some questions. If you don't like to answer these questions about strings now, because everyone should know it, you can of course ask him in the kitchen in the short break we will have. But here's one question.
So it's not only about strings. So you mentioned that the strings cannot be removed from string pool. Does it mean that we can easily create get OM with this, or is it still some possibility there to for garbage collector, for example, to come and
oh no, the garbage collector will do that. It just what I meant is that you can just not do it just manually, like with some line of Java code or something. I do not even know. I mean, I'm not a garbage collection specialist there, but it might be with some hacks possible somehow. But there's no feature just like this, clean this up or something easily. So yeah, but obviously if something is not used, the garbage collector might remove this. But I think that's a quite difficult topic. But there is not that you can simply say, okay, I have the string here, please remove that from the string pool, just like this.
Okay, thanks.
Some more questions.